Hello, good evening everyone. Am I audible? Hello, good evening everyone. Am I audible? Yes. So what were we discussing in the last class? What were we discussing in the last? How did it go? How was your quiz? Did it go well? And what about your assignment 22 sensor? Work on it. Everyone, please do respond. Okay, good. Yeah. So in the last class, is everything clear about how to interface a DHT22 sensor, then how to read the values. Okay, then what is the difference between millisecond? Millis don't block our code. Is that part clear? Okay, good, Lakshmi. Gagan, still now your issue is not fixed, Gagan. But I did not see any question from you in the discussion forum, Gagan. Okay, fine. We'll proceed further. Okay, we'll proceed further. Yeah, so what are things we are going to do today? So what we are going to do today is nothing but we are going to connect. Okay, we are going to connect the our Arduino Uno to the Ethernet shield. Okay, why shield? Because Arduino cannot connect to the internet. It doesn't have that facility. So to add on that facility, we will be connecting Ethernet shield and we'll make sure that our Arduino Uno communicates with internet. It gets connected to internet. Then we will install a library core and test the message on the topic, whether you are able to send the data and receive the data. That all things we are going to see here. Okay. Yeah. First is nothing but what Ethernet shield. We are going to discuss about what Ethernet. What is this Ethernet shield? Ethernet shield adds wired network connectivity to the Arduino Uno. It uses W500 and W 5500 Ethernet control communicates via SPI bus. Okay, and it is tagged directly to the Arduino Uno board, and we don't require here breadboard. So actually, what happens? We are having what the Arduino Uno. This Arduino Uno is non-IP capable device. This Arduino Uno is non-IP capable device. What do you mean by non-IP capable? Any idea? This is a non-IP capable device. Non-IP device, I can tell. What do you mean by non-IP? Non-IP, everyone? Any idea? Arduino Uno cannot connect to internet. This Arduino Uno, what is happening? It cannot get connected to internet. Okay, this they not get connected to what internet. Okay, we'll be using one more additional device which will help us to connect this Arduino Uno to the internet. What is that additional device? Means Ethernet shield. That is nothing but what Ethernet, the Arduino Uno to the internet. So it uses this Ethernet controller IC. This IC helps us to connect the Arduino Uno to the internet via Ethernet shield. So handles TCP/IP stack in hardware, supports four simultaneous TDP/UDP sockets. Okay, don't want to just this much is enough for us. Okay, then how to interface this means we have to interface MOSI and serial clock lines of this Arduino to the Ethernet shield. So here in between them, we will be using a connection called SPI bus. We'll be using here SPI bus in between. Same wires only. Will be as a power supply. Okay, that is already connected for us on our simulator. So we'll quickly go and do the connections and come back and see the other things. Okay, come back and see the other things. I will show you how Ethernet shield looks like. Connections we are supposed to do. Okay. So here I minimize this. I'll open PiximLab quickly. So I'm opening PiximLab. Everyone, are you clear? Why do we need Ethernet shield? Why do we need Ethernet shield? Is it clear? Everyone, why do we need Ethernet shield on Arduino Uno? Is it clear? Okay, Laya. Vidyashri, can you just send a mail to the UWin manager? Please send a mail to the UWin manager. Voice is not clear. Am I not clear? Everyone not audible? Yes, Anil, am I not audible? Is my voice not clear, Anil? Yes, right. Better now? Yeah, is it fine now? Okay, is my voice still breaking? Is video still blur or it's fine now? Okay, fine, we'll proceed. So what I was explaining means I was explaining about the Ethernet shield. Okay, why Ethernet shield? Why do we require Ethernet shield? Okay, on the 1 minute. Yeah, is my screen visible? Okay, 1 minute. Is my screen visible now? Is my screen visible now? Yes, all good. Network. Okay, voice, video, audio, and share screen. Is everything good? Shall I proceed further? Okay, fine. Yes. So what I was talking about is Ethernet Shield. So what we have our Arduino Uno. Arduino Uno is a non-IP capable device. Okay, since it is a non-IP capable device, what do we need is we need a Ethernet Shield. What this Ethernet Shield will do means it will allow us to connect Arduino Uno to the internet. It will allow us to connect what? Arduino Uno to the internet. Okay, this Ethernet Shield will connect to the internet and Arduino Uno to through SPI bus. Through SPI bus. Through SPI bus, what will happen? This Ethernet shield will connect to the Arduino Uno. Yeah. So we'll proceed further. Yeah. So now what I'm doing is I'm going to tell you how to connect Arduino Uno to the internet. Okay, how to connect the Arduino Uno to the internet. So I am opening a Pixim lab. This is my Pixim lab. Okay, and this is our Arduino Uno board. Our Arduino Uno board don't have any way to connect it to internet. We don't have any way. It doesn't have Wi-Fi also. It doesn't have Ethernet also. Neither Wi-Fi nor Ethernet. See, you may be aware of this. If you want to get connected to the internet, your device should either connect to the Wi-Fi or it should connect to the internet. It's an Ethernet. Okay, through wire, Ethernet, wireless, Wi-Fi. Either of the two things should be there, or two modules should be supported to connect your device to the internet. Correct? If I take example of your smartwatch, can your smartwatch connect to internet? Can your smartwatch connect to internet? Can your smartwatch connect to internet? See, it again depends upon some smartwatch. Some will not, some will yes. Okay. Yeah, most of the smartwatches only get connected to what? Bluetooth, no internet, okay, or no Wi-Fi. They don't connect to Ethernet also, neither Wi-Fi. It might not support both of them. Okay, same way here, your Arduino device also doesn't support Wi-Fi or Ethernet. There is no Ethernet port or there is no supporting of Wi-Fi here. So we need extra hardware to connect this Arduino to the internet. So that extra hardware is nothing but what? Okay, Ethernet shield. So go to the spare parts. Go to the spare parts. In the spare parts, go and choose other. Go and choose other. In that, the first device ETH W5500. ETH W5500 is a Ethernet shield. Is a Ethernet shield. So you can see this is how the Ethernet shield look like. This is how the Ethernet shield look like. So this device or this particular whatever the device is there, this will help us to connect the Arduino Uno to the internet. This is nothing but what you see here. This color. This is nothing but a cable port, Ethernet cable port, Ethernet cable port. This is Here in real time, if you see, it is a simulator, but if you see in real time, okay, this particular board will be having that Ethernet port. Okay. Then next, what we are having properties. In the properties, there are the connections. Miso should get connected to 12. Mose should get connected to 11. Reset will get connected to reset. Okay, chip select will get connected to pin number 10. And clock will get connected to 13. Okay, can you just do these connections later? Do it. Okay, Miso of the Ethernet shield to the pin number 12. Okay, you have to just go and select them. Mosi, you can just take screenshot and save it so that you can do connections later also. Just take this screenshot and okay, do the connections later also. Miso pin number 12, Mosi pin number 11, reset to the reset, CSCS to the pin number 10, okay, interrupt no connections, then serial clock pin number 13. So like that you have to connect your Ethernet shield to these okay wires. Like that you have to connect your Ethernet shield to wires. Miso 12, Mosi 11, reset, chip select to the pin number 10, serial clock pin number 13. And one more thing, this Ethernet shield, since it is a simulated one, right? You can turn it on and turn it off. How means? Okay, if you just click on this, it will turn off. If you click on this, it will turn on. Click on this, Ethernet shield will turn off. Click on this, Ethernet shield will turn on. Like this, you can reset your Ethernet shield. Sometimes, okay, you will find difficulty in connecting the Ethernet to your board. That means you can reset it by pressing here. You can reset it by pressing here. You can reset it by pressing here. Is this clear till here? Yeah. Then proceeding further. Okay. So this is about how to connect the your Arduino Uno to the Pixim lab. Further, we'll proceed the few things. Next things. Yeah. So now coming to the our project. Why we are connecting our board to the internet? What is the requirement? I just told you that this Ethernet shield is used to connect our board to the internet. Why should we connect our board to the internet as part of our project? As part of our project, why should we connect our board to the internet? What is the requirement? Assignments will be graded later at the end of your okay project only it will be graded. Okay. Why should we connect our Arduino Uno to the internet, or why we want to connect it to internet? What is the requirement as part of a project? Anil, Laya, other people, Lakshmi, to monitor sensor data. So to monitor sensor data, why should we connect it to internet? To get real time data. Where we are getting this real time data? Means where? Why internet? Yes. What is our intention for our project? Means what is our intention for our project? Okay, we have to send, we have to collect the data. See, as per previous classes, what we have done is we have connected. First, we understood what how to use Arduino. Okay, then we understood how to read the readings from the sensors. Yes, we are able to control the LED. We are able to read the values from the sensors. What is our next step after collecting the data? On the Arduino Uno, after collecting the data, what should be our next step? Okay, we are collecting the data from the sensors. We are collecting the data from the sensor. We are able to control the LED. This we have understood. What should be our next step? After collecting the data, what you want to do with that data? Yes, we have to send that data to the cloud. We have to send that data to the cloud. Which is the cloud platform we are using here? Which is a cloud platform we are using here in this project? Which is a cloud platform, Sangeeta, Monica, Param, Naveen, Navina? Yes, things board is our cloud. To send that data to the cloud, we require what? Internet connection. So we understood how to do the internet connection. Now, when we are pushing the data from the device to the cloud, when we are pushing the data from the device to the cloud, it's non-IP capable device. To make it IP capable, we are using Ethernet shield. Then from there, we are pushing the data to the cloud. Ethernet shield. This combined together will connect to the cloud. Okay, what is the cloud we are using is things board. Yeah. So we understood why we require Ethernet shield. Okay, we understood, right? Why we require Ethernet shield, we have understood that. Next part is when I'm pushing the data from the Arduino Uno to the cloud, we are going to use one particular protocol here. We are going to use one particular protocol called MQTT. MQTT. It's a protocol. Protocol rules. Protocol is nothing but rules. We are going to use these rules to send the data to the things cloud. So let us go and understand about these rules, okay, how it works, and what we have to take care it in the coding, how we can use this in our coding to send the data to the cloud. Okay, going proceeding further. Yes. What is MQTT? So next what we are going to learn here is the protocol MQTT. What is MQTT? MQTT is message queuing telemetry transport. Message queuing telemetry transport. It's a lightweight protocol which works on pub and sub model. protocol designed for IoT devices. It is peculiarly designed for what? IoT devices. A central broker route the messages between the publisher and subscriber using the topics as address. Using topics as address. Okay, your Arduino UNO publishes the sensor data to the topic. Example topic here. Otherwise, I'll come back here. 1 minute. Yeah, MQTT. It is a lightweight protocol. What do you mean by lightweight? Let me explain you why you are calling this as lightweight. Are we going to measure it or something? It's not like that. Okay, let me give you one analogy. Suppose your network is very poor. You're on your mobile phone. Your network is very poor. You're not having 5G. You're not having 5G or 4G. Nothing is there. The network is very slow. That time you're trying to send three things to your friend. One, a text message, one, a voice message, and one, a video message. So which will go faster? Like, which will go first? You are transferring three things at a time: text, voice, and video. Which will go first? Yeah, text message will go faster. Text message will go what? Faster. Why text message will go faster? Why text message will go faster? Yes, it is having less size. It is having what? Less size. They are nothing but what? Okay, why it will go faster? Because when you don't have a stable internet, the lightweight message will go fast. Lightweight message will go fast. Okay, that is called lightweight. So this MQTT supports, it's a lightweight protocol. It's a lightweight protocol. Okay, it's used to transfer small messages. Only the small messages. Using this MQTT, you cannot send a video, you cannot send a audio and all. It will only transmit a very smaller size of data. So it's called a lightweight protocol. Okay, since it's lightweight, it is used in IoT devices. Why in IoT devices? Means IoT devices will be having constraints. Okay, what are the constraints? Means limitations. IoT devices are having limitations. They don't have proper network. Okay, and don't have proper processing speed and all. They'll be having limitations. So lightweight protocol, specially designed for IoT. MQTT is a lightweight protocol, specially designed for IoT, which will work with limitations. Which will work with what? Limitations. Okay. Then coming to the next thing. Yeah, it works on pub and sub model. It works on what? Pub and sub model. So where have you heard this word pub and sub? Publishing, subscribing. Where have you heard this word publishing and subscribing? Alpha, can you stop pushing the messages here? You're disturbing the other class which is going on. You can send your messages to the UWin manager email ID. Please stop disturbing the class. Okay, Tata Playbox, publishing and subscribing. There you have heard. Okay, then where have you heard this publishing and subscribing? Yes, correct. YouTube. In YouTube, in your Tata Play box, yeah, you have to subscribe to this particular channel to view this. You get that messages if you're not subscribed it. Yeah, IPL is going to start soon. Yeah, Amazon, Netflix, you have to subscribe to particular OTT subscriptions. If you subscribe, okay, what do you mean by subscribe? If you subscribe, then only you will be able to see the content, right? If you don't subscribe, then you will be not able to see the content. Yeah, then it comes to YouTube. In YouTube, what do you mean by publishing and subscribing? In YouTube, what do you mean by publishing and subscribing? Yeah, you subscribe some channels in YouTube. Why do you subscribe? So that you get a notification if there is any new content published. If you have any new content getting published, you'll get a notification that some new video has been published. You can watch it. So for that purpose, you will subscribe it. Okay, there individual person don't come and tell you, I have put a new video, please watch it. Whoever is managing the channel, that person will not come and tell you, okay, watch the video I have posted. No, it is not one to one messaging. He will just push the data on the YouTube, and whoever has subscribed the channel will get the notification that, okay, there is a new video, watch it. Same thing here also, same model is implemented between the devices to communicate. Same model is implemented in the devices to communicate. Okay, so here I'm not taking the cloud example. First, we'll understand simple example. Then we will see how to do it on the cloud. Okay, so in the publisher, we'll be having three devices: publisher, then a broker, then we'll be having a subscriber. Then we'll be having what? Subscriber. We'll be having three devices in the MQTT: a publisher, subscriber, and a broker. So what is this publisher? What is a subscriber? Means publisher can be a IoT device, any device that want to send the data, or it can be any cloud platforms which want to send the data. It can be device, it can be cloud, anything. Whoever wants to send the data, they are publishers. Who are trying to send the data, they are publishers. Subscribers, again same. IoT device, if it wants to receive the data, or it can be the cloud which you want to receive the data, anything. Okay, one who wants to receive the data will be subscriber, one who wants to send the data will be publisher. Example, I'll take here Arduino. I'll take here what? Arduino. So now Arduino wants to send some data, to some other Arduino. One more Arduino I'll take here. One Arduino here, one more Arduino here. Okay, so this Arduino node 1, I'll take this as node 1. And this one as node 2. Yeah, they want to send message. Node 1 wants to send some message to the node 2. Then what will happen? It will publish the data on a particular topic to the broker. It will send that data to the broker. Okay. Suppose it want to send a message, about temperature. So it will tell temperature will be the topic. Here we have something called topic. This topic will act like address actually. Topic will act like what? Address. Topic. Then it will send a message 25. Topic and the message 25. Okay, on the topic, it is sending the message, okay, 25. So what will happen if node 2 has to receive that data? If node 2 has to receive that data, then it has to receive like this. Okay, topic. It has to subscribe to the topic called temperature, and it has to get the message. Okay, 20. It will get the message as 25. It has to subscribe to this topic. It has to subscribe to this topic to get that message. It will just subscribe to the topic temperature. If it has to subscribe, this will publish. This will publish on a particular topic, particular message. What node to, if it wants to receive, it has to subscribe. It has to subscribe on that topic. Then it will receive the message. This will subscribe. This will publish. Getting my point? Suppose if you have one more device, we have one more device here connected to the broker. See, broker can connect to the any number of devices. Broker can connect to the any number of devices. Now, what is this broker means? It is one software. What is this broker means? This is one software. This software you can install on your laptop, which will act like a local broker, or this can be running on the cloud. It can be installed on your laptop. This can be running on the cloud privately, or it is available. Public cloud also is available. Public cloud is also available. Public cloud means anyone can publish, anyone can subscribe on this broker. Here in the private cloud means you can set a password and user ID. You can set a password and ID. So broker is nothing but a software, okay, which will be which can be run on a laptop or it can be used on the cloud. So what this broker will do means it will get the message from the publisher and push message to the subscriber who has subscribed to that topic. Who has subscribed to that topic. Suppose if I have one more device here, if I have one more device, if I have one more device here, device 2, it also wants to receive the data. It also wants to receive the data. Then what will happen? Okay, it also has to subscribe to the same topic temperature. But there is some other data which it wants to receive, not the temperature. Then it has to subscribe to that topic. Example, if node 1 is pushing the data on topic called LDR and the number like 10%, topic is LDR, message is 10%. If a device 2 has to receive that message means device 2 has to subscribe to that topic called LDR. Subscribe to the topic LDR. Is this clear about publishing and subscribing? Everyone, are you clear with publishing and subscribing? Okay, fine. We will proceed further. So only one concept, a device want to push the data, it will publish on a topic. If a device want to receive that same data means it has to subscribe to that topic. Topic is nothing but act like an address. Topic will be acting like an address here. Yeah, publisher. Okay, your Arduino pushes the sensor data on the topic. So you can topic can be like this also, like a file. Okay, you have file hierarchy, right? Home bar temperature means this temperature sensor belongs to home. Any connected device can listen to the same topic. Okay, what is a broker? A broker receive all the messages and routes them to the matching subscribers. Okay, no device to device connection needed here. What will happen? Okay, there is no connection between node 1 and node 2. No connection between node 1 and node 2 means no direct connection between node 1 and node 2. All the devices will connect to what? Broker only. So what broker will do? Broker will accept the messages from the publishers and send the data to the subscribers whose topic is matching. Send the data to the subscriber whose topic is matching. What broker will do? Broker will receive all the messages from the publishers. After receiving that message, it will send the message to the nodes who are subscribing to that topic. Yeah, your Arduino publishes the sensor data. So the broker will receive all the messages and routes them to the matching subscribers. Okay, there is no direct device to device connection required here. Then what subscriber will do? Subscriber registers the interested topic, on what topic it wants to receive the data. So when publisher sends the data, the broker delivers it to the all active subscriber instantly. It will deliver that message to the all yeah. So what will happen when a publisher sends the data, broker will deliver to the all active subscriber instantly. Publisher pushes the message to the broker. Broker further will send the message to the subscriber based on the topic, based on the matching topic. When it is sending the data, it also sends the messages on the topic. Okay, fine. We'll proceed further. Okay, here I have the block diagram again. Yeah, publisher, Arduino UNO. Okay, subscriber can be a dashboard, it can be a laptop, another Arduino UNO or a mobile app, anything it can be. Okay, so publisher pushes the message to the broker, then broker send the messages to the subscriber based on the topic. Yeah, then one more thing about the topic names. Okay, during publishing, okay, you have to specify the topic names. Okay, so topic names can be any, like whatever you want. You give some meaningful names. Suppose I am trying to push data from home. Okay, home. Otherwise, I'll take example of a factory only. Our factory node 1. Okay, then from there I'm going to send the data about temperature. So like this, I can create a hierarchy which will give the meaningful name. Smart factory. Smart factory, node 1, temperature. You are trying to publish temperature of node 1 belonging to the smart factory. That's what you are trying to convey here. So like this, you can give any topic name. Topic name can be given by you. Okay, when you're publishing, you can specify the topic name. So you can give the meaningful name like this. Okay, then publish one more thing also. Smart factory node 1, then LDR. LDR is not there in node 1. LM35 or vibration, I'll take. So of node 1, you're trying to push the data about vibration. Okay, on the other side, this is what from node 1 you are trying to push this data on this topics. This is node 1 topics. This is node 1 topic. Suppose on the cloud side, on the things board, okay, whether you want data of about temperature or whether you want data about vibration or whether you want both the data on the cloud side. On the cloud side, you want the data about node 1 about temperature or vibration or both. Yes, everyone, what do you need? You need on the cloud side, you want data about temperature or data about vibration or both. Everyone, please do respond. Yes, you need both. So then what you have to subscribe? What you have to subscribe on the cloud side? You have to subscribe to both the topics. Okay. So what we can do, smart factory, node 1. Okay. So if you publish, subscribe something like this, hash. Okay, if you subscribe something like this topic. If you subscribe like this, okay, this is called wildcard. If you subscribe like this, it is equivalent to that you're subscribing both the topics. It's equivalent that you're subscribing what? Both the topics. Okay, it's equivalent that you're subscribing the both the topics. Vibration also, temperature also. If you have this hash. If you are subscribing to this topic, it means you are subscribing to the both the topics. This is called wildcards. They are called what? Wildcards. Okay, they are called what? Wildcards. Okay, then one more wildcard also there. Okay, now I am trying to publish data from both node 1 and node 2. Node 1, I want to publish the data temperature. On node 2's temperature also I want to publish. So from different devices, I'll be pushing the data. From node 1, I'll push temperature. From node 2, I'll push the temperature, and these are my topics. This is how I'm creating the topic. Smart factory node 1 temperature, smart factory node 2 temperature. On the cloud side, I want both the temperatures. On the cloud side, I want both the temperatures. That time what I can do here is, okay, instead of subscribing to the two topics, I can subscribe it like this. I can subscribe it like this. This is equivalent to subscribing both the topics. This is equivalent to subscribing both the topics. It means anything here. It can be node 1, it can be node 2. This is one wildcard. Okay, this is like anything in between, but temperature you're subscribing. Here, okay, node 1 is fixed, followed by anything it can be. Followed by anything it can be. It can be vibration, it can be temperature. So these are the two wildcards which will help us to subscribe to the multiple topics at the same time. This will help us to subscribe the topics at the same time. Plus and hash. Subscribe multiple topics. Subscribe multiple topics. Fine. Now next we'll proceed further. Yeah. So here, which is the broker? Already I told you the broker can be three possibilities here. One thing is you can install the broker on your laptop, make it work, or you can use the broker that is running on the cloud. Okay, with the password and unique ID. One is public cloud where you don't need password, unique ID, anything. Okay. So here for this now, okay, as of now we are not going to push the data and try it on the cloud. That we'll do tomorrow. Okay, tomorrow what we will do is things board. Okay, we'll configure and we'll push the data to the things board. In today's class, we will use this broker. Okay, broker himq.com. Okay, this is a public broker. This is what public broker. Okay, why public broker? No setup required. It's a free public MQTT broker. No account required, no password required, no firewall. Just connect, publish. Just connect and publish. So this is we are just trying to test. I want to just show you how can you push the data and how can you receive the data, or how can you publish and how can you subscribe. For test purpose we are using this, but our intention for the project is to use thingsboard cloud. For our project we'll be using thingsboard cloud, that we'll see later. The broker running on thingsboard only we'll use. For now, in order to test, we'll be using the free broker. I can tell this is free also, a free public broker. Then connection details, the port number is 1883. Okay, then important notes, don't push any. Okay, 1 minute. Yeah, in the client ID should be different, unique client ID. Whenever your devices are connecting, like here, I'm trying to connect device. I have to give the names for these devices. We have to give the names for these devices, and they need to be unique. See, everyone, don't copy my name only. The unique name I have given in the code. You don't copy the same thing. Give something different, or generate some random number. That is also fine. Yeah, the device name should be unique. If the same device names are connecting means it will fail. Okay, device name should be unique, and don't publish any sensitive data. Don't publish any sensitive data on the shared brokers. Okay, so that you have to take care when we are using the public brokers. Okay, so when we are publishing, we have to pass this address. This will be address of the broker. This is a port number. This is a port number. You can see here it's client ID. You can use some random number here. Use some random number to avoid the if it is not unique ID, then it will not work. So give some random number. And topic names also keep it unique. Okay. So we'll see how to do that now. Already I showed you how to connect this. Leave this. Yeah. Now if I want to use this, MQTT, right? I have to install one library on our Arduino. I have to install one library on the Arduino. I will show you how to install it. Otherwise, let us install, do it side by side. I'll open Arduino IDE. Okay, Arduino ID is opening. Yeah. So we have to install a library. Go to the library manager. Go to the library manager and search for PubSubClient. PubSubClient by Nick O'Leary. We have different libraries, but use the library used by Nick O'Leary. Yeah. PubSubClient by Nick O'Leary. Install it. Install this library. Okay, to use the publishing and subscribing. Yeah. Once you do that, next thing. Then we need Ethernet.h that is built in. You need not install here. Okay, next. Okay, so what we are going to do here is use a public broker, no local setup required. Define a broker host name as a string and create a Ethernet client. Okay, so here what we will be doing means first include that library PubSubClient. Okay, this will be nothing but we need to publish and subscribe. We need this library. Then here MAC address of your Ethernet shield. Then here broker, this is nothing but the address of the broker. Const char star broker is nothing but what? Address of your broker. So address of the broker here is broker-mq.com. This is a public broker we are using for now. But this will change when we are using Thingsboard. This will change when we are using Thingsboard. For us now our broker is HiveMQ. HiveMQ is our broker. Then we have to start Ethernet board by setting the Ethernet.begin. After that, client.setServer. Client.setServer means here we are requesting for the connection. We are requesting for the connection to the broker. There we have to pass the There we have to pass the broker address. We have to pass the broker address. Then we have to pass a port number. This is port number. Then this is address. Here we are passing the broker address. Here we are passing the port number. Yeah, this should not come inside loop. I changed it. I don't know how it got reflected here. Yeah. So next what we have to do is we have to create Ethernet client, object called Ethernet client. Then we have to create an object called client by passing Ethernet client. So here we are creating two objects. One object is Ethernet client for Ethernet connection. Okay, client for pub and sub. Okay, to publish and to subscribe, one more object client. Okay, Ethernet client, which will create a TCP socket used by MQTT client. Okay, then here client set server is nothing but we are connecting you to the your broker, the HiveMQ public broker. Okay, this should come here. I don't know. I changed it, but still, this should come here. First, create a Ethernet object. Okay, then create a pub and sub object. Ethernet object to connect to the internet. After that, pub and sub object is to publish and to subscribe. Okay, so here what we are doing is, but we are just setting the server. So once your board is connecting to the broker, if the board is connected to the broker, it can publish, it can subscribe. Okay, how to publish, how to subscribe, we will see it. Yeah, so we have a function called reconnect here. The MQTT connections can drop. Always call client.loop inside a loop function. Inside loop, we are calling client.loop. Okay, so implement a reconnect function that tries with a delay to avoid the hammering of the broker. So what will happen? Your device should always get connected to the broker to send the data and to receive the data. Your Arduino device should always connect to the broker to send the data and to receive the data. There is a possibility that it may drop the connection. So we have to make sure that when it is not connected. So you can see here, if the client dot not connected, if this is true, then we are calling a function called reconnect. Then we are calling a function called what? Reconnect. Okay. So when the reconnect, what we are doing, we are waiting till it gets connected. If the client is not connected, keep looping here only. Keep looping here only. Okay. Inside loop, what I'm doing, I will try to connect. Call a function client.connect. Pass here what? The ID, the device name. And I'm telling this device name need to be unique. This device name need to be unique. Then once it got connected, print it's got connected. So you can check here, I'm trying to connect every, okay, 5000 milliseconds, which is nothing but 5 seconds. I'm trying for reconnection for every 5 seconds. For every 5 seconds, if it is not connected, for every 5 seconds I'm trying to reconnect. Yeah, if it's getting connected, I'm printing the message connected. Is this part clear? Here just we are making sure that your device is connecting to the broker. If not connected to the broker, every 5 seconds I am trying to reattempt for a connection. Trying to reattempt for a connection. Then publish, okay, test message to the topic. Okay, so what we are going to do here, we have function client.publish. So here we have to specify the topic, what you want to publish, and the message, what you want to send. Okay, so it can be home, sensor, temperature, and the payload can be a string or a byte array. Okay, so here you can see client.publish, a topic on what you want to publish, and the message what you want to send. This is a message, this should be a topic name. So what we are doing here, we are creating the topic. Topic is home, sensor, temperature. Okay, so string payload. I'm creating the payload as a string. Okay, which is 24.25.4. This is my data. Then what we are doing is we are reading that data and publishing it. Okay. We are reading analog read A0, storing it into a message, and what we are doing is we are publishing on that topic. Okay, client.loop must be called regularly to keep the MQTT connection alive. Then here the string function which will convert the float reading into a string. Float reading into what? String. This function will convert the reading whatever it can be into the string. String is one data type. Okay, just remember this part. This is important for us. These all things are fine. This part and this part is important. How to publish on a particular topic, pass the topic name and pass the message. Client.loop should be called inside loop function to keep the connection alive, to keep the MQTT connection alive. Then how to receive the message? How to receive the message? Okay, use client.subscribe function after connecting. Define a callback function that fires when message arrive on the subscribe topic. Register it with client.set callback before calling the connect method. Okay, so what we are having here is a callback function. We'll come back to that later. Okay, when what we are doing here, we are checking if the client is connected. Once client is connected, we will subscribe on a particular topic. So you can see this is a message. Client.subscribe. You have to specify on what topic you want to receive the data. On what topic you want to receive the data. Okay. Then here we are setting up the callback function. We are setting up the callback function. Means once you receive the data, which message need to be, which function need to be called. If you receive a message, which function need to be called. So I am setting the callback as callback. So this function will be called whenever you receive the message. So in the callback, what we are doing is we are just printing the received message. We are just printing what? Received message. Okay, I'll once, Everything I will once show you in once. I will try to brief it out. So already I told you what is this client dot connected. It will tell you whether it's got connected or not. Connection failure. Okay. MQTT connections drop due to broker restarts or network timeouts or Wi-Fi glitches. Okay. So what will happen here? Common causes are broker offline, network cable unplugged, firewall blocking. So this can be the issue. So here we can understand whether it's got connected or not. So here what we are doing, the client dot connect, we are checking. Okay, it's got connected or not. If not, we will call the function reconnect. Okay, so I'll brief out once all the functions and you will get a better idea here. So what we'll be having, a broker. Okay, here we have the Arduino code. Okay, so on the Arduino, what is happening? We are using different functions from pub and sub library. What is library? Pub and sub library. In that pub and sub library, we are using few important functions. Let me explain that. Okay, first one is client loop, that will keep us to help the connections alive. It will help us to keep the connections what alive. It will keep checking it keep a broker connected or not. Okay, then if the client dot connect, the client dot connect will tell if it is connected. Okay, if it's not connected, we'll call a function called reconnect. Client client dot connect, connected. The client is connected or not. If not connected, we'll call a function called reconnect, which will help us to reconnect, which will help us to connect back the Arduino to the broker. Two things. Next, two more important functions. Just remember them. One is client dot publish. One is client dot subscribe. Okay, client dot publish is for what? Okay, to send the data. So you can put a topic here. You can put any topic here. Okay, so let me take a topic as Arduino test Arduino UNO bar data. I'm trying to send some data. Okay, to receive, I'll just receive back that on same device. I will send also from Arduino and receive also on the Arduino, just to test it out. Just for testing, what we will do, we will send the same data and we will see. I will subscribe to the same topic to see that whether we'll get the data or not. Okay, so you can use this client.publish. What you have to specify here, the topic followed by message. I'll send a message, hi. I'll just send message what? Hi. Or what you want to send, hello. I'll just send a hello. I don't want to make it complicated, so hello. Okay. Then we'll subscribe on the same topic. Unsubscribe on what? Same topic. Okay. To publish, we use this function client.publish. To subscribe, we will use this function client.subscribe. In publish, topic and the message. In subscribe, only topic. Then you have received now some data. Okay, you subscribed, so you'll receive some data. So what should happen when you receive the data? Okay, so whenever you receive the data, you have to set a one callback function. We have to set one callback function. Set callback. Callback means this function will be automatically called. This function will be automatically called when you receive the message, which is that function called callback. Okay, set callback. You can give any name. I'm giving callback. You can give any name. Okay, or you can give the name as or print also. Give the name as print message. So this message, this particular function will be called whenever you receive the data. Whenever you receive the data, it will be called. How? Because we are setting it. We are setting it as what? Callback. We are setting it as what? Callback. Okay. Yeah, so remember this. So what you are doing here, we are sending the data, receiving the data, setting the callback means whenever you receive any message on the Arduino, okay, this will be fired. It means this will be called immediately. This function will be called. Which function will be called? This function will be called print message. Are you clear what is client.publish, client.subscribe, client.setback, set callback? Are you clear? Yes, we'll go and quickly see the code. I have already uploaded the code in the LMS. If you want, you can refer it. I will show you. In the LMS, already have uploaded it. MQTT sample code day 6. You can just download this code. Okay. I'll open the sample code here. Not very clear. Okay, at least these two things are clear. That is enough. Publish, subscribe, that you understood. Publish is to send the message, subscribe is to receive the message. That you understood. If I want to send any message, then on a particular topic, I have to send it. If I want to receive the same message, then I have to subscribe to that topic. Is that part clear? Yeah, we will see it again. Okay, we will try to change something in the code and try to understand. I have opened the code here. Okay, here I'm using the library SPI.h, Ethernet.h, and PubSubClient.h. These are for internet connection. This is for pub and sub connect, publishing and subscribing. This is a MAC ID of our device. This is dummy actually because our device is not a real-time device. It's a dummy device. So this MAC ID is also dummy. Okay. So here this is a broker. So which is a broker we are using? Public broker, Hive MQ. Broker address here. Then publishing topic, I am taking it as Arduino UNO data. I am subscribing to the same topic, Arduino UNO data. I am publishing also on the same topic, subscribing also on the same topic. Since I am doing this, whatever Arduino, whatever data we are transmitting, same data we will receive. Whatever data we will be transmitting, same data we will receive. Okay. Then we are having Ethernet client. I'm creating the object Ethernet client. Okay, I'm creating the MQTT like PubSub client. This I'll come back. So in the setup, what we are doing, we are setting up the baud rate. We are establishing the Ethernet connection, giving certain time. Then MQTT set server. Here we are establishing the connection to our server. We are establishing the connection to our server. See here one more thing. I have created here object as MQTT. You may get confused, so I'll just change it to client because till now I have told you it as client. You can use client or you can use MQTT. Any name. You can use my name also. Okay, Jaya. But it belongs to pub and sub. Okay, I have shown you example client. Here I am using MQTT. So both are fine. Yeah, MQTT, what we are doing here in the setup. Okay, what we are doing here, connection, request connection to the, what we are doing here, requesting, requesting connection to the broker, to the broker. Then here we are setting a callback function. Here we are setting what? Callback function. So if any data is received, okay, call this function. Any data received on the your Arduino device, on the Arduino via MQTT. Then this function, which function callback will be called. So in the loop, what we are doing, we are checking if MQTT got connected. If not connected, we are calling a function called reconnect. We are calling a function called what? Reconnect. Okay, these all things I will not do. It will be more confusion. I'll just remove them. I don't want to make you confused here, so I'll just remove them. Yeah, first we'll understand this. Okay, what we are doing, if it is not getting connected, we are requesting for reconnection. Then MQTT dot loop, this is nothing but client dot loop, same thing. Okay, then we are publishing here. So we are publishing on a topic, pub topic, that is nothing but this one. Arduino UNO data, this is our publishing topic. What I'll try to publish means I'll try to publish hi or hello. I'm just trying to publish hello. I don't want to make it complicated, so I'm just publishing hello. Okay, after publishing, we are printing the message published. Okay, hello, I'm publishing. Then in the reconnection, what we are doing, if it's not getting connected, if MQTT not connected, we are trying to connect to the broker, and I'm giving the name here. This is our Arduino name. Okay, so give any random name, give random number. Otherwise, what will happen? Connection will not happen. Connection will not happen. Give some random name, random number. It'll get connected and we are subscribing to the topic. Same topic we are subscribing. What is that? Arduino UNO data. Arduino UNO data. Then in the callback, what I am doing? In the callback, okay, whatever message we are receiving, we are just printing it. Whatever message we are receiving, okay, the topic, payload, length, okay, we are printing it. Received, on what topic we have received and what is the message we have received. We are printing it. In the callback, we are printing it. Okay, so try to understand here particularly about loop. In the loop, what we are doing is we are checking if it is getting connected or not. If it's not getting connected, we are making the connection. And when got connected, we have subscribed to the particular topic. Once connection is established, we are publishing on a particular topic. So what we are publishing? Hello. Okay, what is the topic? Arduino UNO data. And what topic we are subscribed? Same topic. So we should get the same message. I am publishing what from the Arduino? Publishing hello to the broker. And what topic? Arduino UNO data. So what will happen on Arduino? I'm subscribing to the same topic. I should get hello back. You're sending hello to the broker, and you'll get hello back on the Arduino. You'll get hello back on the okay. We'll just upload this and see the output. Few more things we will discuss later. Otherwise, just to make it easy, I will make the topic also easy here. Let the topic be also test. Topic is test. But I'm not sure this will work because it's very common name. And you testify. See, your this topic should be unique because we are using the public broker here. So if anyone has also published the same thing, then you will get some other random data. Example, you don't say use the same topic as I have used. Otherwise, you will get my message. Yeah. So on the Arduino broker, what you're publishing on the topic test file. On the topic testify, what is the message you're publishing? Publishing hello. Okay, to get the same message, you are subscribing to the same topic. Okay, you are publishing on a topic testify, you are subscribing on the message on the same topic testify. So you'll get hello back. You'll get hello back. You are sending the data and receiving the same data. We are just trying to test this. We are using here the local broker as Hive MQ. Fine. We will just one. Okay, one bracket is extra. Okay, what I will do here is load X file. I have this in my sample course. Excuse me. Build. Yeah, so here is my code. Yeah, connected to the broker. You can see here. Hello, hello is getting too much time. Wait, I have to provide delay here. Some delay I'll give. Some 1 second delay I'll give. It's happening too fast, so I'm just giving a delay here. Yeah, you can see here. Okay, published. Hello is received. You can see published and hello is received. For every 1 second, I'm publishing the data and we are printing the received data. What is received? Hello is received. After publishing, we are printing, it is published. Okay, whenever data is received, a callback function is called on what topic you are receiving the message and what is the message. Fine? Yes. We'll stop here for today. Okay, can you tell me what all things we have discussed in today's class, everyone? What all things we have discussed in today's class, everyone? No idea. Yeah, how to connect the Ethernet shield and about the MQTT. Yeah, so what will be the homework means study about MQTT. Okay, and try to publish and subscribe. Okay, please do some hands on the publishing and subscribing. Okay, yes, thank you everyone. You can leave. Good night. Okay, more about what to study and the study material. I'll be uploading it in the LMS. Please refer the study material, study it, and also some homework will be given. I'll be putting it there. Okay, you upload it. Yes, good night, everyone. Thank you.